Assalamu alaikum and good evening, everyone. Today we are going to start May-June 2023 paper 1-1 of AS level chemistry. Let's start with question number 1. Okay. Do keep the periodic table with you and the constant values information with you. Okay. So element X has 6 more protons than element Y. Which statement must be correct? Okay. So they have mentioned two elements. So one is element X, whatever its proton number is, let's say its proton number is B. So when 6 protons are further added in it, then it becomes element Y. So element Y have, okay, let's make it C. So element Y has C plus 6 protons. Is this understandable to all of you? Okay, now we have to check which statement is correct. First, they are saying atoms of element Y are smaller than atoms of element X. Okay, let's have a look at the periodic table. Here we go. So, for example, let's assume it is X. If there are 6 more protons in it, so its proton are 3. So if 6 protons are added in it, so 6 plus 3 makes it 9. So 9 protons is this fluorine. So then Y must be fluorine. So as we know, when we move across the periodic table, what happens to the atomic radii? When we move across the periodic table, atomic size decreases, right? So it means that this statement might be correct, but think further. For example, if let's assume element X is boron, and boron has a 5 protons, so 5 plus 6 makes it 11. So it means then sodium has 11 protons, so it becomes element Y. So if we compare boron and sodium, so obviously sodium has a bigger size because it has a 3 shells and boron has a smaller size, which makes this statement wrong. So this statement cannot be correct every time. Is this clear? So if this statement is wrong, then it means that the statement D, that as some of the students tell me that statement D can be option. So see, element and X and element Y are in the same period. So it's not possible, right? So A is wrong, D is wrong. Is this understandable? Because they are saying that element X and element Y are in the same period, right? So how is this possible? For example, if element X is a boron, let's assume, then element Y must be sodium, right? So see, they both are in the different period, isn't it? Is this understandable? Yeah, but it is not only the possibility, Hadi, because they are saying that there is one element X and there is one element Y. So it is not necessary that it, for example, if element X is beryllium, then element Y can be a neon, right? If element X is lithium, then element Y can be a fluorine. So in this case, they are in the same period. But for example, if element X is any element from these groups, then the element Y must be in the other period, isn't it? Is this understandable? Yes. Let's have a look. Now, what they are saying, element X and element Y are in the same group. So is this possible? That if we add 6 protons and make it in any other group, it turns into be the same group? No, it's not possible in any case. For example, if it's lithium, so the after adding 6 more protons, it can be F. If sodium, then it can be chlorine. If beryllium, then it can be neon. If magnesium, then it can be argon. So see, they can't be in the same group both. Is this understandable? So it means that statement C is wrong as well. So if these 3 statements are wrong, then it means that the only correct option would be B, and B is the correct answer. See how they are saying element X has a full shell of electrons. So it is a possibility that if element X has a full shell of electron, so if it is element X, they didn't tell us about element Y except that it has a 6 more protons than element Y. So then if we add 6 more protons in it, then element Y would be this one. If element X is this, then element Y would be this one. So this can be any possibility. Yeah, element X can be the one which has a full complete shell. So B is the correct answer. Now question number 2. Which statement explains why calcium has a higher melting point than barium? Okay, calcium cation are smaller than barium cations and have a stronger attraction to the delocalized electrons. Yes, higher melting point is means that it has a stronger forces of attraction. Yes, Anshara. So calcium has a smaller cation, right? So Ca has a smaller size. and barium 2 positive has a bigger size, and both have a same charge. So obviously it's going to be attract the electrons more stronger than the barium. So that can be an answer. But let's justify the rest of the three and mark them wrong. Then you are going to consider A correct. Remember, if you read the first statement and you find it uh, if you find it, some statement correct, but do, confirm that the rest of the statement must be wrong. So B, the structure of a calcium is partly giant molecular. No, it's not molecular. So B is wrong. There are more delocalized electrons in calcium than in barium. No, because they both have a 2 positive charge. So it means that their electrons, oh, 1 minute, my screen is not sharing. Okay. So it's not giant molecular. And the C option, there are more delocalized electrons. So that's wrong because both have a 2 positive charge. So it means both loses same number of electrons. So C is also wrong. Now D, there is a greater repulsion between barium atoms and have no more complete electron shells than calcium atom. So the repulsion would not be greater because the nuclear charge is obvious, is because barium has a more number of electrons, so its charge density is obviously smaller. So D is also wrong. So yes, A is a correct answer. Now, question number 3. Three statements about potassium and chlorine and their ions are listed. The atomic radius of potassium atom is greater than the atomic radius of chlorine atom. Okay, let's have a look. Chlorine is in period 3. So it means chlorine has 3 shells, right? And potassium is in period 4. So it has a 4 shells. So yes, potassium is bigger and chlorine is relatively smaller. So first statement is I seems correct. Okay. Now, the first ionization energy of potassium is greater than the first ionization energy of chlorine. Okay. So potassium has a bigger size. So obviously more shielding effect is there. So statement 2 is wrong. Okay, good, Hassan. The ionic radius of potassium ion is greater than the ionic radius of chloride ion. So when the chloride ion forms, its radius remains the same, but when the potassium ion forms, as the fourth shell, is, removed because it loses its valence electron. So the size of potassium ion is not going to be greater than the chlorine. So that is wrong as well. So yes, very good, Hassan. So only first statement is wrong. And if the first statement is wrong, oh, sorry. So only first statement is correct. So A is the correct answer. Is this clear to all of you? Now question number 4. For which equilibrium do both the equilibrium constant Kc and Kp have no units? Okay. So if I write the Kc expression for this one, that the concentration of hydrogen iodide square upon concentration of hydrogen times concentration of iodine. Yeah, I think so. And so there are two concentrations above and two concentrations below. So if I put the unit mole per dm cube, so mole per dm cube square over mole per dm cube times mole per dm cube. So in the denominator and numerator, both there are squares, so there would be no unit. So if I write the Kp expression for the first equation, so partial pressure of hydrogen iodide over partial pressure of hydrogen times partial pressure of iodine. So it is also going to cancel out. So here over here we got the square. So all the units must be cancelled out for Kp as well. Yes, for A is a correct one, B is not correct because here we got 2 moles of gas and here we got 4 moles of gas. So we must get some unit over here. In the same way, 1 mole and 2 mole. So that is also, there would be no unit over here. There would be a unit over here, and over here there is a 1 mole, and over here there is a 1.5 mole. So over here as well, there is no unit. Oh, there must be a unit. So when the gas moles are equal, then in that case only there would be no unit. Now, question number 5. Calcium carbide CaCO2 reacts with water as shown. The data below the equation shows in kilojoule per mole the standard enthalpies of formation of the compounds involved. Okay. What is the standard enthalpy change of the reaction shown? So see, they have given you here the enthalpy changes of formations of these compounds, and they are asking you to find the enthalpy change of this reaction means X. So if you recall, for this, we always put elements when we make the, Hess cycle. We put the elements over here. Whenever there is a formation, we do this. From elements, we make these arrows. So this is your indirect route and this is your direct route. So it means that if I put the expression, so it is going to be, if I make the expression, it is going to be minus 60 plus minus 286 plus x is equals to minus 635 plus 228. So if you solve it for the x, so x is equals to minus 6. Let me write it over here. X is equals to minus 635 plus 228 plus 60 and plus 286. Can anyone solve it and tell me the answer, please? Think. Minus 61. Okay. So A, C, and D are wrong, and B is the correct answer. Okay. Now, question number 6. In sodium chloride lattice, the number of chloride ions that surround each sodium ion is called the coordination number of the sodium ions. Okay. What are the coordination numbers of the sodium ions and the chloride ions in sodium chloride lattice? Okay. In sodium chloride lattice, the number of chloride ions that surround each sodium ion is called the coordination number. So if you recall, we know this, that around one sodium ion. Yes, very good, Hassan. There are 6 chloride ions like this in a lattice. One is right, one is at left, one is at top, one is at bottom, one is at front, and one is at below. So that goes with each chloride as well, that with each chloride ion, 6 sodium ions surround each chloride ion. So if you see, if let's assume the chloride which is on the right, on its left there is a 1 sodium ion, on its right there is a 1 sodium ion, on its top where there is a 1 sodium ion, on its bottom there is a 1 sodium ion. On its front, there is a one sodium ion. So on its back, there is a one sodium ion. So if you see for both, there are six sodium ions surrounding one chloride ion, and there are six sodium ions surrounding one chloride ion, and in the same way, there are six chloride ions surrounding one sodium ion. So the answer is going to be C is the correct answer, and A, B, and D are wrong. Now, question number 7. Histidine is an amino acid. Okay. What are the approximate bond angles 1, 2, and 3? Okay, let's have a look. If you look at bond 1, so we can easily see that over here around this carbon, there are three bond pairs, right? And as there is a carbon, so in carbon, there is a no electron of the valence shell which is left behind, all involved in the bonding. So there is a no lone pair over here, right? So in this case, when there are three bond pairs and no lone pair, then that case bond angle is going to be 120 degree. Yes, very good, Anshara, very good, Hadi. Now, if you see nitrogen, nitrogen is in group 15 and it has a one lone pair. So for nitrogen over here, there are three bond pairs and one lone pair. So in this case, bond angle is, if you recall, 107 degrees. Very good, Hassan. Now, if this three, there are four bond pairs and no lone pair, right? So if this is the case, when there is four bond pair and then no lone pair, the bond angle is 109.5 degrees. Yes, very good, Hassan, Hadi, Amna, Anshara. So A is wrong because this statement is wrong. And if you see 2 is 107, so C and D is wrong because C and D says that angle 2 is 120. So we are left with only option B. So B is the correct option. Okay. Now, question number 8. The contact process takes place at the pressure between 100,000 pascals and 200,000 pascal. A catalyst is used. Which statement is correct? A V2O5 catalyst is added to increase the equilibrium yield of the reaction. So if you see contact process is to make sulfuric acid, so for this V2O5 is used, but it is to increase the rate, not increase the equilibrium yield. So this statement is wrong because catalyst is not added to increase the equilibrium yield, it is added to increase the rate. So A is wrong. Now B. Changes in pressure have no effect on the position of equilibrium. So if you recall, this reaction is an equilibrium reaction. So there are different moles of gases on both the sides. there are not equal number of moles of both the sides. So obviously, different change in pressure affects the equilibrium. So B is wrong. The equilibrium yield of reaction is very high under the conditions used. Yes, because if you see the pressure is very high and there are less moles on the product side and there are more moles on the reactant side. So we know that higher pressure shifts the equilibrium where there are lesser number of moles. So it can be correct. And iron catalyst is added to increase the rate of reaction. So yeah, the catalyst is added for the to increase the rate of reaction, but iron catalyst is not used over here. It is used in Haber process. So D is wrong. Yes, Anshara. Good. So C is the correct answer. Is this clear to all of you? Now question number 9. Bromine reacts with aqueous sodium hydroxide at 25 degrees Celsius. Okay, this is reaction 1, which is occurring at 25 degrees Celsius. It is the same reaction as chlorine. Okay, as the reaction of a chlorine with sodium hydroxide, that's what we have studied. The NaOBr formed is unstable at 25 degrees Celsius and reacts further. It's reaction 2. Okay. Which reactions are disproportionation reaction? So this is for sure disproportionation reaction 1 is because see, bromine has oxidation number 0 and here it's -1 and here it's +1. So if you see here it's +1, it goes -1 and it goes +5. So yes, this is reaction 1 is disproportionation reaction and as well as reaction 2 is also disproportionation reaction because in both reactions oxidation number are changing. So both are, I think my screen is, yeah, let me share it again. So both are disproportionation reaction because in both the one element is being oxidized and reduced. So A is correct and B, C, and D are wrong options. Which statement is correct? The relative atomic mass of chlorine 35 is 35.5, not wrong because it's chlorine 35, so its relative atomic mass is 35 only. The relative formula mass of calcium carbonate is 100.1. Okay, we will see. Is it 100.1? Okay, let's have a look. Calcium is 40.1. Okay. Calcium is 40.1. Oxygen is 16 and carbon is 12. So 40.1 plus 12 plus 48. Because it's a isotope. See, they have mentioned chlorine 35. So chlorine 35 has a atomic mass, has a relative atomic mass of 35, and chlorine 37 has a relative atomic mass of 37. But if they say just if they didn't mention this and then they say that, and see, it's chlorine atom, they are not talking about the element. So they are talking about specific isotope. So the specific isotope has a specific mass of 35 and 37, not 35.5. That is why A is wrong. Okay, Mariam. So if we add them, we got 100.1. So it is correct. Okay. For magnesium atom, it's 20. So the relative isotopic mass, no, it's 24, so its relative isotopic mass must be 24. So this is wrong as well. The relative molecular mass of O2 is 16, it's O2, so it is going to be not 16, but 32. So D is wrong as well. So B is the correct answer. Is this clear? Yes, Mariam, did you understand why A is wrong? Iodine and propanol reacts according to the following equation. If the concentration of propanol is increased, keeping the total reaction volume constant, the initial rate of a reaction also increases. What could be the reason for this? Okay, so if we increase the concentration, a greater proportion of collisions are successful at the higher concentration. No, the proportion remains same because there are more concentrated, but if the greater proportion of collision occur only either when the catalyst would add it or temperature is increased, not by increasing the higher concentration, proportion stays the same. So A is wrong. The particles are further apart at higher concentration, completely wrong. When the concentration is high, okay, Hassan, let me check. The particles are closer together. The particles have more energy at higher concentration. No, their energy remains same. There are more collisions per second. Yeah, because there are more number of particles. So there could be more collisions per second between particles at a higher concentration. Yes, it's correct. So D is the correct answer. Okay. Now, question number 12. For successive ionization energies of element E are shown. Okay. Element E is in the period 3 of the periodic table. Okay. In which group of periodic table is E? Okay. So from this, if you see, there is almost a difference of 4,000. There is almost again a difference of 4,000. And there is almost again a difference of 5,000. So it's the 8th one. And it is the 5th one. If there is a, no, it's not greater gap, it's almost considerate gap. So it means that if you see this, This will help you to understand that these all are the electrons in same shell, isn't it? So if they are all in the same shell, yes, very good, Anshara. It makes B, C, and D incorrect because it's not from group 15, group 16, and group 17 because there is a not a big gap. So if these three are wrong, so we are left with only A option, which must be correct. So there are some cases where you are unable to find the correct one. So I always suggest everyone to go for the wrong one first. And if you're able to find the wrong ones, then you will always going to end up the correct one correctly. So as they all are in the same shell, which clearly indicates that group 15, 16, and 17, the element must not be in these groups because it doesn't have a 5, 6, or 7 electrons in its valence shell. So then we are left with only option A, which is group 14. Okay. Now, question number 13. In this question, you should assume that the gas found behaves as an ideal gas. A 1.7 gram sample of magnesium reacts with 50 centimeter cube of 2.2 mole per dm cube HCl at 303 Kelvin and okay, this Pascal. Which voluminous gas is produced measured under this condition? Okay. Can anyone help me finding the moles of magnesium? For moles of magnesium, we divide this mass with 24.3. That is the relative atomic mass of magnesium, C 23. So can anyone tell me the moles of magnesium? What moles of magnesium I am getting? It's 0.0699. Okay. So these are the moles. Now, let's have a look at the equation. When magnesium reacts with HCl, we are going to get magnesium chloride and hydrogen gas. If I balance the equation, I need to put a 2 over here and the equation is balanced. So if you see the mole ratio of magnesium and the hydrogen gas is 1:1, right? So it means if these are the moles of magnesium, 0.0699, then the moles of hydrogen produced must be 0.0699. Is this understandable to all of you? Now, we are going to use the expression PV is equals to nRT, where we have to find the volume. For volume, it becomes nRT over P. So remember, the moles are 0.0699 times R, that is the gas constant. And gas constant, if you don't remember, its value is given over here at this page. This value 8.31. So 8.31, temperature is always taken in Kelvin. So they have given it in Kelvin. So times 303 over. Yeah, there is a one more thing I ignored. Okay, 1 minute. The pressure is 110400. Calculate the moles of HCl as well. So moles of HCl would be 50 is the volume times concentration, which is 2.2 divided by 1000 to turn it into decimeter cube. Can anyone calculate it and tell me? No, it's not necessary. We have to check it. That how many moles are there. It's just 0.11, Hadi, Hassan, or there is some extra figure as well. It's 0.11 only. Okay. If you look at this ratio, we got its mole are 0.11. and its mole that are used is 0.0699, right? So for this, as you see, the mole ratio between these two is 1:2, isn't it? So if these are the number of moles, so do it times 2 and tell me what answer you are getting. Multiply 0.699 times 2. My screen is again stuck. Yes, can anyone times 0.699 times 2 and tell me? See, you are getting 1.398. So it means the number of moles, listen to me very carefully. Okay. The number of moles of magnesium. Okay, it's 0.1398. Okay. So the number of moles of magnesium, for these number of moles, I need this much amount of HCl are needed. But this amount of HCl is present, which makes it a limiting reactant and makes it in excess. So see, we always use the calculation with the limiting reactant. Because if these are the moles of magnesium, for these moles of magnesium to completely react, we need this much moles of hydrochloric acid. But in actual, we have only 0.11 mole of hydrochloric acid. Is this understandable? So whenever they have given you the amounts of two reactants, always convert them into their moles and then identify whether they are in the perfect ratio or which one is a limiting or which one is the reactant is the excess one. So it means I'm not going to use 0.699. Instead, I'm going to use, okay, 0.11. Now, if you see the mole ratio between these two, the ratio between hydrochloric acid and hydrogen is going to be 2:1. So you need to divide by 2, you need to halve the moles of HCl to find the moles of hydrogen that are formed. So can anyone divide it? So on dividing it, I think what we will get 0.055. Is that what we will get? No. Can anyone tell me? 0.055. Okay. So these are the moles that I'm going to put over here. So 0.055 times, then I'm going to get the correct answer. So can anyone calculate it and tell me the answer, please? Yes, please. Can anyone? So it's you are getting 1.25 exponent minus 3. And it's a meter cube. And these are given in decimeter cube. So always in this, when we find the volume, that volume is always in meter cube. So you have to divide times it 1,000 to turn into decimeter cube. So when you divide times it 1,000, it is going to be 1.25, isn't it? So if you see, it's 1.6, it's 2.5, it's 5.0. So A is going to be the correct answer. Is this understandable? Now, question number 14. Chlorine dioxide reacts with aqueous sodium hydroxide to produce water and a mixture of two salts, NaClO2 and NaClO3. Okay. What is the mole ratio of NaClO2 and NaClO3 in the product mixture? Okay. So for that, you have to make the equation. Okay. So let's have ClO2 reacts with sodium hydroxide to produce NaClO2, NaClO3 plus H2O. Now, if you see over here, this chlorine has an oxidation number of +4. This chlorine has an oxidation number of +3. and this chlorine has an oxidation number of +5. My screen is again stuck. Okay, so I am writing twice because to referring it. So see, it is changing from +4 to +5, which means oxidation. And this one is getting changed from +4 to +3, which is reduction. So if you see, one electron is lost and one electron is gained, right? So the number of electron lost and the number of electron gained are equal, isn't it? Because one changes from +4 to +3, it means it gains one electron. And the other one changes from +4 to +5, which means it loses one electron. So the number of electron transfer or electron loss and gain are equal. So if there are two chlorines, so we need two sodium, right? And for two sodium, there are two sodiums over here. And how many oxygens over here? 2, 2, and 2, 6. 2, 3, 5, 5, and 1, 6. Yeah, the equation is completely balanced. And now if in this balanced equation, if you see the ratio of both of these, they are existing in the ratio of 1:1. So if they exist in the ratio of 1:1, which makes A, B, and D wrong, so C is the correct answer. So you need to balance the equation, the redox equation. And after balancing, if you get any ratio over here, for example, if you got the ratio of 1:2 over here, so this could be answer. If you got the ratio after balancing 3:5, then this could be an answer. Is this understandable to all of you? Okay. Now, question number 15. The temperature of a sample of an inert gas is increased. Okay. What effect does this have on the number of molecules with the most probable energy and on the number of molecules with the higher energy? So if you recall the Boltzmann distribution constant at a normal temperature, this curve is like this, right? So it is the most probable energy, right? And it is the highest energy. Is this understandable? So when I increase the temperature, on increasing the temperature, what affects it? It goes like this. So see what happens at most probable energy, that the number of molecules are decreasing at most probable energy. So it means C and D are going to be the wrong answer, right? And at highest energy, the number of particles are increasing. So A is going to be the wrong because it says it decreases and these two says it increases. So we are left with only B. So B is our correct answer. Is this clear? Okay. Now, question number 16. For which compound is there a greatest percentage loss of mass on strong heating? Okay. So for a nitrate, for a carbonate, if you decompose it, it turns into this and this. So only 44 grams has been lost from the solid, right? For a nitrate of group 2, metal oxide is formed. Further, 2 moles of nitrogen dioxide and half mole of oxygen is formed. So half mole of oxygen is 16 gram and 2 mole of NO2, nitrogen is 14 and 32. 32 and 14 is 46. So 46 times 2 is 92. Yeah, 92. So see, this much mass has been lost. So it means for the carbonates, it's wrong. Now we are left with magnesium, calcium carbonate and magnesium nitrate, right? Calcium nitrate and magnesium nitrate. So between these two, calcium has a MR of 40 and magnesium has a MR of 40.1 and 24.3. And the nitrate has actually a mass of 92 and 16 is, can anyone add 92 and 16? Yes, sometimes. 92 and 16 is 108 plus. So 108 is lost from 14 plus 16 because it's a calcium oxide, right? And here 24.16 is left and 108 is left. Is the mass of solid over here. It is the mass of solid which is left, and this is the mass which is lost. So in both the mass loss is 108, but here the leftover mass is less. So the greatest percentage would be D, not B. So D is the correct answer. Is this clear? Relatively more mass is losing in D. Okay. Now question number 17. The solid sodium chloride and sodium iodide both react with concentrated sulfuric acid at room temperature. So if you recall, over here only HCl is formed, but over here further iodine is formed as well. With the NaCl, the products are NaHSO4 and HCl. With sodium iodide, the products are NaHSO4, hydrogen iodide, iodine, SO2, H2O, sulfur, and H2S. What is the explanation in the difference in the product? So the only difference is that it is the stronger reducing agent. Chloride ion will displace iodine from the solution. No, chlorine will displace iodide from the solution. So he is completely wrong. The more reactive halogen displaces the less reactive halide ions. Hydrogen chloride is more volatile than hydrogen iodide. Yes, it can. This is correct, but it is not explaining the above one because it's just they are talking about the boiling point. Okay, Hassan, let me see. Iodide ions are better reducing agent than chloride ions. See, that's what I have told you. It is the stronger reducing agent. So C can be a correct one. Sulfuric acid is able to act as a dehydrating. No, here it is not acting as a dehydrating agent. Here its action is as a oxidizing agent. If you go through the notes, you will find it. So we are left with only C option. So C is the correct one. Now question number 18. SiO2 has a melting point of 17-13 degrees Celsius. It reacts with hot sodium hydroxide to form sodium silicate and water. No reaction occur when SiO2 is added to hot sulfuric acid. What can be deduced from this information? So it's an acid and it's an base. So it means it is acidic. That's why it is reacting with the base, and it is acidic. That's why it's not reacting with the acid. So behavior of SiO2 is not amphoteric. On being amphoteric, I mark them wrong. And SiO2, if you recall its structure, it's giant, not simple. So being writing simple, D goes wrong and C is the correct answer. Is this understandable? Yeah, very good, Anshara. Very good, Hassan. Now, question number 19. Element X has the second largest atomic radius in its period. An atom of X has 3 occupied electron shells only. So it's in period 3, obviously. An oxide of X is shaken with water. What could be the pH of the resulting solution? Element X has the second largest atomic radius. So if you see from period 3, when we move there, the atomic radius decreases. So the second largest would be magnesium. And for magnesium, if you recall, when magnesium dissolves, if X is a magnesium, its oxide is dissolved, so it forms a weak base because it's a partially soluble, right? So it's a weak basic, right? So if it's a weak basic, so it can't be A and B. No, it's a weak base, so it can't be 14. So 14 is the strong base. So C is the correct answer. Because it's a magnesium oxide and magnesium oxide is a weak basic. Now question number 20. Which emission from an internal combustion engine contribute to erosion of the marble statues? So marble statues are calcium carbonate. So it means the one which contributes must be acidic gases. So it's Carbon monoxide is neutral, so A is wrong. Nitrogen is nothing to do with it, so it's wrong. Unburnt hydrocarbons are also neutral, so it's wrong. So then C can be a correct answer. Is this clear? Okay. So we are ending the class over here. We are done with the half of the paper, and the rest of the half we are going to do in the next class tomorrow. And if I do the tomorrow's class at 5 p.m. PST, is this feasible for all of you? Okay, so tomorrow we will have a class at 5 p.m. PST, inshallah. Okay, so take care, everyone. Goodbye and Allah Hafiz.